Hi, I'm Esther.
And I'm Sean.
I write about AI news here at Tech Target.
And I edit Esther's stories.
We're here to talk to tech experts about everything AI, from open and closed models to AI agents and who's ahead in the generative AI race.
And even the elusive AGI.
We've got it covered, right, Sean?
Yep, we've got it covered. Hi, everyone. Welcome back to another Targeting AI podcast. Today, Olympia Brickis from Siemens is joining us. Olympia is the Director of Research at AI Research at Siemens. She's been with Siemens for more than 7 years. Before Siemens, Olympia was a lecturer at the University of Bremen in Germany. Thanks so much for joining us on today's show, Olympia.
Thank you, Sean and Esther, for having me. Super excited to talk about this topic with you guys here today.
So we like to start by getting to know you better. Like, how did you get to be the director of AI at Siemens, and when did your whole journey with AI begin?
Yeah, it really started when I was an undergrad. I was an undergrad in math, studying in Munich at the TUM Munich, and I realized I wanted to do something that's a little bit more applied than pure mathematics. And so that kind of took me into the field of computer science. And when I ended up studying computer science in my graduate degree, I realized that really AI laid at this intersection of math and computer science, and I really got very excited about it with a couple of my peers that were studying with me. It was a very exciting time for AI at that moment. So we were studying basically on the brink of ImageNet having been introduced, computer vision models going through the roof, new architectures coming out every year that were really improving performance tremendously. So we were learning a lot in those years about deep learning, about how to build these type of models. So that's how I got into the field of AI. And in my last couple of years of grad school, I did an internship at Siemens. Siemens, of course, is not necessarily somebody you associate with AI innovation when you come from the outside. Though if you get into the company, you realize that perception is actually quite wrong. Siemens has been working on AI for a very long time, since the 70s, actually. And I joined the exact team that was behind those original days of AI at Siemens, the internal R&D organization in Munich. And that exposed me to a new field of application of AI, namely the field of industrial AI. And I really learned through that internship how much I can add in value as somebody who comes from the field of computer science when I join forces with engineers, with operators, with domain experts in industry that kind of want to apply those new technologies to their domain. And so in contrast to all of my peers that went into tech companies, that went into startups, that did a lot of consumer AI in those days, I decided to take an offer and stay with Siemens in that department and focus on industrial AI research. 2 years into that job, I got the opportunity to come to the US and lead one of our teams here that specifically focuses on AI research in the United States for Siemens. We're part of the global organization, and we work with the customers, the problems here in the region, as well as kind of this general question of how do we make AI robust in industrial applications. So yeah, that was basically my journey into the role where I am today. I'm very privileged to work with a great team of engineers and scientists and developers here that drive our mission to solve the problems that we really see emerging when we bring AI into industry.
Yeah, that's very interesting. And for those who don't know, can you speak a little bit about industrial AI? Because like you mentioned, whenever we talk about Siemens, no one is thinking AI company, right? So what is industrial AI? How has it changed or grown in the past couple of years with generative AI?
Yeah, Esther, great question. I mean, like you said, when we hear AI today, the first thing that jumps into our minds is probably generative AI and ChatGPT, language models, right? And we know them from using them ourselves. And while those applications of AI are very exciting, our personal assistants or the recommendations that you get on Netflix for what movie to binge next, those type of applications are very different than industrial applications for AI. So in the industrial world, when we apply AI, we are dealing with environments that are much more critical. So any decision that you take in a plant, be it a manufacturing facility or be it an electrical facility, an electrical plant, your decisions and the actions that you take are much more critical. So the AI consequently has to be much more resilient and specifically tuned to this type of environment. So industrial AI for us are any applications of AI in the industrial space in industries, and by that we mean production, manufacturing, but we also mean electrical grids, trains, mobility, engineering tasks, essentially any industries that you can think of that are not just your personal use of AI. And interestingly, in those fields, I mean, I could give you a couple of examples that we kind of always give for industrial AI in the space. Like for instance, if you are in a data center, AI oftentimes takes the task of optimizing the control of the HVAC system, such that we can more efficiently cool the data center and because of that, save energy and save cost for operating the data center. So be more efficient in our operations. And these decisions are very hard to make for humans because they have to be made in milliseconds, considering a huge variety of data and information to really find those optimal set points for the many HVAC systems that you'll find in big data centers. So that's just one example of how AI is going into that, into industrial fields. And I want to mention as well that it's not just about optimizing the machines in the field. So industrial AI oftentimes also connotated with just dealing with machines. It is really about the people that operate those machines and empowering them as well on their in their daily tasks. So I think it's a mistake if you just think of industrial AI as something that is just steering this gray infrastructure that we have that is kind of dead, right? I think it's very much something that interacts with humans, that needs human input, that assists humans that are operating those facilities.
So you mentioned obviously the people that are operating them. Is there a little bit of fear, especially because this kind of like this, you have this artificial intelligence coworker working with you, and now is there like a need to know programming or something in terms of AI for those who are working with the technology?
I think like for everybody of us, there's always a learning curve if you get a new technology and it starts assisting you in your day to day, right? So we do see that we have a little bit of learning periods when we introduce this technology, but at the same time, a lot of these industries deal with incredible talent shortages due to their workforce aging and many people with a lot of knowledge of how the systems operate retiring. So we see actually a lot of acceptance and excitement with many of our customers to try out these technologies and see how they can empower, especially those younger workers that are coming in with less experience about the system and kind of want that little assistant that sits on their shoulder and can kind of guide their way as they get to know the plant or the infrastructure that they're operating. So I think, yes, there definitely is a learning curve, but also a lot of excitement.
Olympia, I wanted to just follow up with something Esther actually mentioned earlier that how have you transitioned from traditional AI? You mentioned that Siemens has been in AI since the 70s. So, predictive AI, machine learning, as opposed to generative AI. So are you using it mostly in the form of like assistants or agents, or how are you using, multimodal models or stuff like that?
Yeah, Sean, great question. So I think there was definitely a huge mindset change happening in the AI research community, both industrial and non-industrial, in 2022 with this jump that we saw in performance in language models. These language models have essentially taken us to think less about AI as something that you have applied to a very specific and narrow problem, and has taken us to thinking of AI as something that is more of a general tool that can be prompted or triggered in ways that it applies to the context in which it's used by humans. And I think that is a mindset change that we have been seeing in industry as well. So we are going also away slightly from just models that are geared to the super narrow use case that you very often had to train or fine tune yourself as an operator. You had to invest a lot of time to get there. We're going away from that and seeing models that can be applied much more out of the box in these settings. But to your point, actually, it's not the models that we're seeing out there in coming from our colleagues at OpenAI, Microsoft, Google, that we can apply in industry straight away. Because the one challenge with those generative AI language models or even vision models that we're seeing is that they're trained and geared towards general purpose use cases, non-industrial use cases. So for instance, to give you an example, we are utilizing generative AI to help automation engineers and on our PLCs. And we tried using those models that are out there first to see if they can program SCL language, so our semantic structured control language. And they were like okay at it, but really, if you wanted to go that last mile and make the code that you were programming really great and resilient and be able to do a variety of things, that's when we saw no, we need to take a step. We need to go a step farther and really fine tune those models and build dedicated industrial models for these domain specific languages. So that's just one example of how we are extending this. And I could give you some more on multimodality, also a very exciting topic for industry to think about. Yeah, but that's maybe one to start with.
What are some of the other problems and challenges unique to industrial AI? I mean, obviously you have the fast moving, real world, real time, uh, um, floor of the manufacturing facilities. So there are any specific challenges, and are there specific challenges in specific industries?
Yes. So you're right. The real world connection is really something that is quite different in industrial AI than we have it when we just use ChatGPT to write an essay or get a movie recommendation, right? It has two effects. One is that we need to deal with all of this data that is coming in milliseconds. There's usually very large amounts of it, and we need to make this accessible to the AI models. Secondly, we need to make sure we are giving robust and resilient recommendations. We don't want to say something that then gets implemented that's going to potentially impact our operations, right? Put our plant down or something like that. So we do also need guardrails that kind of check with more classic or more symbolic methods that we have already had established in industry for many, many years to make sure that we're saying the right things and that we're kind of pointing the AI in the right direction. So guardrailing and making really the recommendations that are coming out resilient is one of the key challenges. The second one I would highlight is the modalities you spoke about. So modalities means the kind of data we're inputting to AI, right? Commonly, we started out with generative AI with text. You were able to type into your ChatGPT. Now you're able to give it pictures, and it can respond with pictures. But if you think about industry, the type of modalities we're dealing with are actually quite different. While we do have text and we do have pictures, people very often have time series that they need to analyze, sensor data coming in, readings coming in every second. We have diagrams, electrical wiring diagrams. We have process and instrumentation diagrams, PNIDs in process industry. And our experts today interpret those diagrams in their day-to-day when making decisions. And so what we see is that we need models that can interpret this kind of data. And so we are working also on expanding the capabilities here of the models behind the scenes, such that they can really target industrial modalities and become better at operating in those environments.
Yeah, very, very, very interesting. Actually, I'm very intrigued. I wanted to touch a little bit on what you spoke about multimodality and ask: are you creating your own models, or are you working with anyone in terms of those kind of models? Because, like you said, your problems are very unique. You have different data sources than perhaps someone who just needs or companies who need text or video input. And then, how are you guarding all of those data?
Very good question, Esther. So we definitely work with an ecosystem of partners, right? I think AI is not one of those topics that you make happen by yourself, especially not in industry, as we have many an ecosystem of people that are involved in the supply chain, in data ownership, and so forth. So some of our partners are companies like Microsoft and AWS for the backend. So they really make it possible for us to scale our training, our deployment of AI models. So we collaborate with them. We also collaborate and reuse models that are out there already to fine tune them. So for instance, we use the GPT models from OpenAI, and we are looking at other models like Llama. Basically, we look at a whole palette of what is out there, but we do fine tune and we do build models ourselves as well. Particularly industrial models that are geared to the problem settings that we want to apply them to, because we have basically our learning over the past 2 years was that while you can get to a certain level of quality of output with existing models out there, there is a gap. There is a gap that we need to bridge if we want to really make it industrial grade. And this gap is what we are filling as Siemens. Now you asked the second. I think Esther asked the second question, right, about the data part of it. Where does the data reside? How do we make sure that it's safe? So the data that the actual real life operations data that at the end these models are interacting with, that is data of our customers. That is data of the operators of the respective facilities, whether that's a building, whether that's a shop floor, or whether that's a power plant or a train. So the ownership of the data remains with those customers. We don't use the data for our model training, but the great part about working at Siemens in AI is we are a manufacturer ourselves, right? So we manufacture our automation equipment. We have around 300 plants all across the world. And it's not just for our automation equipment, it's for our trains, it's for our switch gears, it's for our building control systems. So we really do collect a lot of data also ourselves in our own operation, and we utilize that data to train the models. So they are not only tuned or improved by our own experience and knowledge of the domain, but really also the data buckets that Siemens itself has access to.
Okay, so you're a really big company with thousands of employees, tens of thousands of employees. So how open are these employees and managers and engineers and workers to accepting AI technology as the latest new things in AI technology? Are they accepting them as the technology is something that helps them, or is it something they resist?
Yeah. Sean, so actually, I was quite surprised by the openness when I initially joined Siemens, and I continue to be impressed by how fast we are at adopting technology. So we are truly at heart, we are a tech company, right? We produce all of these very complex devices with engineering teams behind that. So our spirit is that of a technology company, and so when we adopt when trends like the introduction of ChatGPT happened, we were very quick at putting together a task force that determined what do we need to do as a company to leverage this technology. And I'm always so proud to tell this story because 3 months after the release of ChatGPT, we had a custom instance of ChatGPT in the company available, which we were able to utilize with confidential data from our day-to-day. So that was very impressive. This gave us as employees at Siemens immediately the possibility to see how can this make my day more productive? How can this make me more effective? And we had a challenge, a competition to collect use cases across the company for where do people see opportunities in their products, in their own day-to-day, in whatever they're doing for Siemens. And we immediately collected more than 300 use cases across the company that people just came up with in a week. So the acceptance was really, really great. And then the support and empowerment by our managers and by our IT department that really made that happen, that gave us these models that we were able to play around in a safe and secure environment was what allowed us to be able to say today that we're really using this technology not only in our products, but we're also using this ourselves in our own plans, in our own day-to-day.
What are some of the ways Siemens uses AI both internally and externally? What AI vendors or products do you use and how?
Yeah, so we use internally. We use for our own office productivity and backend offices. We are partnered with Microsoft, so we use their services. We have Azure deployments of various models, not only the ones from OpenAI, but a variety of other models that we can use. And again, like I said, or like I think Sean, you mentioned it, we are a huge company, not only tens of thousands of employees, hundreds of thousands of employees, right? So this is a tremendous global operation that we have going on here. So what we do is really empower everyone to say, how can they employ this best in their day to day? And we give everyone access to the tools in a secure and reliable way to make that happen. So we have use cases, and we have been having them, right? This is not only since generative AI. We have employed AI, also the narrow AI models that existed beforehand, in our supply chain management functions to really track the where our products are coming from. How can we make sure if like a product or part runs out that we find quickly the right one to replace it with that still meets the specs and doesn't jeopardize our product. We are using this AI in our engineering world. So we have actually ourselves been building models that make our products more energy efficient and more resilient. So for instance, when Siemens Energy was still part of our organization, we were building models that made sure that the turbine blades could withstand all the pressure that is being put on them, and that we could predict exactly how those turbine blades would wear, so that we can make them last as long as possible. And then that technology that we developed for sort of our internal engineering efforts, we realized it's not only something that makes us better, it's also something that would make our other companies in the world be able to engineer more robust products. And we put it in as a feature into our engineering software, in our engineering and design software that the Siemens digital industry software portfolio hosts. And so that feature that was initially developed internally for internal purposes made it into something that now any manufacturer, any engineer in the world can use to optimize their designs before even printing anything or before even manufacturing a piece of equipment physically, right? So this is all optimization that you do before you need to invest in physically manufacturing this and physically testing the part.
Like you mentioned, Siemens has been like obviously an AI company for a very, very long time. Uh, are you guys looking at AI agents at all? I mean, do you see a need or a way AI agents could be imputed into industrial AI?
Oh, definitely. So I think agents are a very exciting topic, especially for industrial AI, because a lot of the steps that you have to do in your head, sort of, to come to a conclusion for many of these problems that we're talking about, there's many steps that you need to do in your head, right? As an engineer, you don't just solve one equation and then you arrive at your solution for how the turbine blade should look like. There's many steps that you perform. Similarly, if you think about the entire manufacturing process, from designing a part to testing it, simulating it, and then actually making it physically, it's a very interconnected and long process. So it's not like we can build one AI that's going to be like, oh yeah, I can do this end to end immediately. It's a very complicated thing to do. So where we utilize agents is to take on separate pieces of this entire process, produce the output, and then hand it over to the next agent so that they can continue to work on the task and ultimately achieve that entire value chain. So when you are using, for instance, our Copilot for operations, which is one that assists workers on the shop floor, behind it will actually be a series of agents that are making sense of what you need to do and splitting that task between them, and taking on separate pieces of the task, like pulling out the right data that you need to answer your question, processing that data, asking you questions back if there are some unclarities about what you need, and then really doing the heavy lifting on the math side to come up with recommendations. Potentially, they trigger digital twins that you have of your factory to give you an answer, and then they put it all together into what looks like a simple response that we then get out of the assistant.
Okay, so you just mentioned digital twins. I was really curious about that. You were probably working on with digital twins before 2022, but so have you progressed in your use of digital twins and, let's say, metaverse technology for like remote modeling of stuff and for just modeling of dangerous things before you implement them?
Oh, definitely. So the digital twins are also a key backbone of digitalization in the industrial space, right? They allow us to have an environment where we can try out things, where we can test things. And digital twins can have a variety of complexities, right? Sometimes they are a digital twin for a very small part of the process, like one machine in a manufacturing line. Other times there are digital twins of the entire facility that captured interconnectedness of everything going on. And they continue to be a very important piece, especially as we introduce AI and more AI into our operations, because they are a great way to test out what the answers of the AI. So where we see them becoming even more important than they were in the past is that these digital twins, we can basically test drive the AI recommendations in our digital twin, see how the system would be affected by the recommendation, and then decide, is this something that we really want to recommend? So the AI can start considering that feedback that they are getting from the digital twin. So that's kind of like one way that both of these technologies are actually kind of lifting and driving each other up.
I want to go back a little bit back to agents, and also kind of align with digital twins. Do you ever see a scenario, or maybe it's in the future, where the agents are working behind the scenes, working behind the technology, will be fully autonomous?
Mm-hmm. Definitely. So we have actually, if you had visited us at SPS, which is an automation fair happening in Nuremberg once a year, if you had visited us there, you'd have seen one such application that we had just piloted together with ServiceNow. So there we had an agent that would autonomously send out maintenance requests and service requests through the ServiceNow backend, such that a work order could be dispatched for maintenance automatically once it realized that there was something that needed to be done. So we are definitely seeing potential for autonomy. Now, when it comes to really autonomy downstream, and what I mean by that is autonomy that really starts to close the loop on control. That's where we're working currently on implementing mechanisms that would make that safe. Right, so that you can really be sure that if you're writing back a control instruction onto a machine, into an electrical grid, that those decisions that we have tested and validated them enough such that we can really go that last mile of autonomy. So I would say on that front, there is still a little bit to go on the technology side until we can make that leap. Today, we prefer to keep the human in the loop and have and give recommendations to the human that they can then, to the human operator, that they can then evaluate and make that final call on whether this is a good control instruction to take.
Okay, so let's get a little newsier and more up to date. So, is it true that there's some kind of upcoming changes in your AI strategy? Because we say that because Siemens just acquired a Gen AI startup, right? Physics X, and so they want to do AI based. You want to do AI based physics simulation, I think, and so you also acquired Altar.
Altair, exactly. We partnered with Physics X, acquired Altair. We're evolving. It's part of a strategy that we have for a long time. Both our hardware focused on operations as well as our software focused on engineering and design are evolving with the capabilities of AI. So in the example I mentioned about our turbine blades, that were initial things that we organically developed in the company, but then we're also expanding through those acquisitions, in particular into physics domains that we had not been core part of the Siemens portfolio. Yes, AI in physics is a huge development that is happening. We are seeing it advanced by transformer models, so the technology that is behind the language models in generative AI. It's also advancing how we can represent physics and physical behavior with AI. And those techniques are very powerful, especially for early testing of designs and processes. So while you might still want to run a high fidelity simulation before you really decide to manufacture something or before you decide to put a car on the road, in order to get to that initial prototype of a design that will optimize for the KPIs that you have, be it battery lifetime in an EV, or be it certain aerodynamics of your Formula One racing car. In order to get to that initial prototype, it's great to have this AI available. And our strategy includes advances of AI, to get back to your question, Sean, across our portfolio. So we are a big company. We do a lot of things, and we have AI advancing each one of those fields.
I wanted to ask because about adoption, and what I mean is like, what is the conversation like when you're looking at like maybe the new products that are coming out? How do you decide what to adopt, what to maybe go and create yourself, and what to skip and say, oh, it's not ready yet?
Yeah, great question. It's actually a very tough one to take, right? Because there's so much excitement about technology, but sometimes it's not there yet, or there are steps that need to be taken to make it really robust and ready to be productized. So yeah, we have a couple of approaches to that. So one is our organizational approach, right? We have a very established innovation and R&D team that is horizontal to all of our businesses, and we have experts in those teams. We have actually over 1,500 AI experts in the company that continuously monitor what's going on in those various domains and can make recommendations on that. So that really know the state of the art and know where the gaps are and whether somebody is filling that in the market or whether there's gaps that we don't see anybody filling and that we believe are needed to be filled to achieve a robust adoption of AI in industry, and then we make decisions on whether to build those or to partner with somebody to build them. So that's quite these assessments, these continuous assessments are quite crucial for us, especially as we operate over this wide variety of application areas.
So, Olympia, just before I kind of start wrapping it up and ask the last question, I want to mention two things. First, you're an amazingly articulate and clear explainer of industrial AI, so thank you. Really appreciate that. And you covered a whole range of topics really concisely. And I also wanted to say that we have a huge Siemens plant in my city of Worcester, Mass. So it's a big presence in our city. I just wanted to mention that. I wanted to say, what's in the future for industrial AI at Siemens? What kind of things in the near term and longer term future do you envision?
So there's definitely a lot of exciting announcements to come in the next months and in the next year for us. But what we are really doubling down on is making all this technology advancement available to industry, right? And we talked today a lot about the challenges that brings with it, right? The other modalities that the big tech companies are not necessarily focusing on, the robustness and resilience challenges. We are working on those, and we're bringing out models, or we're going to be bringing out models soon that will address many of these challenges. So I think that's kind of what's in the future and what's making me excited, because we're going to see everyone be much better able to utilize these technologies in the industrial context, solve or address our workforce challenges, address the efficiency gains that we are always striving to get with our operations. And yeah, that is out there. I want to say there's so many things that we still can work on as researchers, as practitioners in the field, even as domain experts, right? I'm sure there's many applications that we have not thought of yet. These advances that we're dealing with in the technology have happened in the last 2 years. That's not a lot of time to really figure out the best ways to use it. So I always also encourage everybody to really see where it can make a difference and try things out themselves to to find those niches, and we're doing so ourselves all the time. So I also expect there to be surprises out there where we find new ways to apply it, and exciting use cases that we have not thought of yet.
Thank you so much, Olympia. We really appreciate you joining us on today's podcast. To our listeners and our viewers, please feel free to link up with Olympia on LinkedIn, as well as check out Siemens. Please feel free to share this podcast everywhere podcasts can be shared, Instagram, all over the social media platforms. And also check out Informer Tech Target's website for more topics like these. And we'll see you next time on the Targeting AI podcast.
To hear the full audio podcast, please go to Apple Podcasts, Spotify, Amazon, Audible, TuneIn, Podbean, and other popular podcast platforms.